have seen that a PN junction allows current only in one direction. When it is in forward bias, current flows through it. When it is in reverse bias, a very small current which we call as drift current, that only flows through it. So it means in forward bias it has low resistance, but in reverse bias the resistance is very high. So if we take it ideal diode, so I will say in forward bias zero resistance and in reverse bias infinite resistance. So let us see how can we plot. Diode characteristics means a VI graph, voltage across the diode and the current flowing through it. So in forward bias, when we apply the voltage, external voltage, the electric field is produced across the depletion layer, which is opposite to the internal field, and a current starts flowing through this diode when the voltage, external voltage, exceeds the barrier potential. So initially no current, but then this is called knee potential. No current will flow till the applied voltage is less than the potential barrier. So this is forward bias. It is non-ohmic because V upon I remains constant in ohmic devices, but here it is not so, though VI graph is not a straight line. In reverse bias, when we connect the voltage, a field is developed which is in the same direction as the internal field. Width of the depletion layer increases and no current flows except a very small current which we call as drift current. So very small current. We can call it reverse saturation current. It remains almost constant. However, at one particular potential, the current is increased to a large value. We call it breakdown voltage. Normal diodes, they don't work in this region. We have to apply voltage less than the breakdown voltage. There are specially designed diodes which work in this region. We call them Zener diodes. So that mechanism will be discussed in Zener diodes. For the time being, just keep in mind that in reverse bias, a very small current flows, which is the drift current, because of the electrons and holes which are created in the depletion layer as a result of electron hole pair production due to thermal energy. In forward bias, no current till the applied potential is less than the potential barrier, and after that current flows. If we have to find out the resistance, then we call it dynamic resistance. We have to calculate like this. It's not constant for different ranges. So we call it dynamic resistance, which means del V, change in voltage for that section for which we want to calculate the resistance, divided by the corresponding changes in the current. So that's all in this topic. Thank you.